Hey guys, so today we're going to be reviewing our properties of parallelograms, and then we're going to go straight to examples. So first of all, let's talk about a parallelogram. It's a quadrilateral with exactly two pairs of opposite parallel sides. You'll notice on my picture, my opposite sides are parallel. Then we have talking about opposite angles. So when I have a parallelogram, you'll see in my picture over here that I'm talking about, our opposite angles are going to be congruent. So if these angles were labeled A, B, C, D, we could say that angle A is congruent to angle C and angle B is congruent to angle D. Next, we talked about consecutive angles. Remember, consecutive angles mean next to. So in this parallelogram, the angles that are next to one another are AB, DC, AD, and BC. We know that those consecutive angles are supplementary. And remember, supplementary means that when I add them together, they equal 180 degrees. We also talked about opposite sides of a parallelogram, and we know that those opposite sides are congruent. Finally, we talked about diagonals, and we learned that they bisected one another. Therefore, we can say that this green piece is congruent to this green piece, and this red piece is congruent to this red piece. Okay, so for the first example, I want you to go ahead and draw this picture in your notebook. Okay, so what we're looking for this time is the measure of E, F, G, and H. What I'm going to do first is I'm going to draw in everything that I know about my line segments on a parallelogram. For example, let me go ahead and name each of these vertices. So if this was parallelogram capital A, capital B, C, D with this point here as P, I can say that AB is congruent to DC, so let me go ahead and draw that in. I can also say AD is congruent to BC. Then if we go in and start talking about our diagonals, I know that AP is congruent to PC. And then finally, I know that PB is congruent to DP. So this information should be able to help us to actually solve for E, F, G, and H. Okay, so let's look at E first. Well, we already marked that E was congruent to BC. We know the length of BC is 12 inches, therefore E is also 12 inches. Let's go to F. Well, we know F is congruent to AB. AB equals 17 inches, therefore F is also 17 inches. G is part of one of our diagonals, AC, and we know that G, or the length of G, is congruent to AP. We know AP equals 4 inches, therefore G equals 4 inches. And then finally H, we know is congruent to DP, which is 7 inches, therefore H is also 7 inches. This should be our final answer. You'll notice that there's not really a lot of work involved in this first example. However, I did have all of my congruency markings on my parallelogram. On your quiz, I'll expect to see those markings to show me your work. For example 2, we know that the figure below is a parallelogram. We also know the length of 3 different line segments. Before we try to find the perimeter of the triangle RZI, we're going to write in everything we know about this parallelogram. Again, this is what I expect to see as your work. So we know that it's a parallelogram, so that means FT is parallel to RI, and oops, I don't know why I put 2 of those there. And we also know that RF is parallel to IT. Okay? We know the length of FT, which is this length here, is 15 meters. We also know that the first diagonal FI is 24 meters, and my other diagonal RT is 28 meters. Well, we learned that the diagonals bisect one another. So if FI is 24 meters, FZ is 12 meters, and ZI is 12 meters. We're just taking the full length and dividing it in half. We can do the same thing. If we know RT is 28 meters, I can divide that in half to get 14 meters for RZ and 14 meters for ZT. So if we now look at triangle RZI, we know 2 of its 3 segments. Well, going back to our properties of parallelograms, we know that our opposite sides are congruent. So if FT is opposite of RI, and we know FT is 15, that means that RI is also 15 meters. So we're not quite done. The question actually asked us to find the perimeter. So what we're going to do is we're going to add up each of the side lengths of triangle RZI. So we have 14 plus 12 plus 15, and when we add those up, that gives us 41 meters. So if I ask for the perimeter, be sure that you take those final steps to add up each of the side lengths. Okay, so we're going on to example 3. Again, be sure that this is drawn in your notebook. So for example 3, it says, what is the perimeter of this parallelogram? Well, we know it's a parallelogram, so I'm going to draw in some information that I know. I know my opposite sides are going to be parallel, but I also know that my opposite sides are congruent. So I know x minus 4 is congruent to 12, and I know that x plus 4 is congruent to this other side here. And so here's the question. I didn't give you the perimeter of this parallelogram. What I did give you, though, is an expression for one side length and a number for what it's congruent to. So if we know that x minus 4 and 12 are congruent, we could write this. X minus 4 is congruent to 12. In this case, we can go ahead and just say that they're equal to one another. And now this is a one-step equation where we can actually solve for the length of x, or solve for x. So we'll add 4 to both sides and we get x equals 16. So what that helps us with is our side lengths that have expressions. So if we come back up to x minus 4, if x equals 16, what we have is 16 minus 4, which gives us 12. We know that this side length is 12, which we already knew. We come over here, if x equals 16, this is 16 plus 4, so we know this side is 20. This side is congruent to its opposite side, so we also know that this side is 20. So now we have numbers for all 4 side lengths. So if we're looking for the perimeter, we're going to add them up, and we'll have 20 plus 12 plus 20 plus 12, which gives us 64. I didn't give you units on this, so we'll just have units. So 64 units is the perimeter of this parallelogram. Finally, we'll on to example 4. Example 4, now we're talking about angle measurements. So we're looking for angle measurements E and M. It says it's a parallelogram, so I can go ahead and draw in my parallel sides, since that is the definition of a parallelogram. Now we can use some things that we learned from first semester geometry. You'll notice I already drew in my first set of parallel lines, and it's transversal. Well, we know that opposite interior angles are congruent. So this is one interior angle, which is 34 degrees. I know that its opposite interior angle is E, and so those two are going to be congruent to one another. Therefore, E also equals 34 degrees. We can do something very similar, or we can just say we know opposite angles of a parallelogram are congruent because we did learn this. So if that's the case, we know that M must equal 132 degrees. And we have found E and M. Alright, so the homework for today is going to be page 283, numbers 1 through 6. I need for you to copy the pictures, but I also need for you to show your work. So for some of the problems like we talked about, that may not require a lot of adding and subtracting. However, I need to see on your picture what you knew to be true. Good luck!